In this video, we're going to take a look at what we call point-slope form. The main idea here is if you're given a point and you're given a slope, you can A, graph any line, and B, write an equation to fit that line. So let's start by graphing a line first. You're given a point, -2, -3, says from the origin you go back 2 units and down 3 units. From there you use the slope. Rise over run, up 4 over 3. 1, 2, 3, 4 in the up. 1, 2, 3 units over. Once you have 2 points, you can go ahead and connect those dots to graph your line. Just a reminder, make sure you draw a long line all the way through with arrows. Now the big idea is there's a way to write an equation with only a point and a slope, and that equation type is called point-slope form. It looks something like this. You want to take the y and the x value for the equation, and notice I have a subtraction sign. All we really need to do is plug in 3 pieces of information. A point which has an x and a y value, an x and a y value, and a slope. Now I did write y, m, and x in very specific positions. The fact that I have 2 y's here can be confusing, the same for 2 x's. So what I'm going to do is I'm going to put a little subscript mark with the x and the y values that I plugged in from the given point. M, once again, represents the slope. This form requires a point and a slope, hence the name, point-slope form. So your point would be x1, y1. And those are the values that plug straight into the equation. The slope is your m value, goes right in the dead center. And that's all there is to point-slope, is substitution of 3 parts. Let's try an example. The first example shown, we want to use the point 1, 4 and the slope of 2/3. So the base equation is y minus some y value is equal to your m times x minus some x value. And all we have to do is plug those points in. The x value is 1, so x's go together. There's your 1. The y value is 4. Your y's go together. And your slope is 2/3. You plug that right in the middle where the original equation showed slope was going. And now your equation is written. There's nothing else to do. Base substitution of 3 pieces of data. What if you get an example where you have an undefined slope? I want to remind you that an undefined slope is a fraction that breaks the rule, such as 3 divided by 0. Your rise is 3, your run is 0, you don't go left to right at all. This is actually a vertical line. Vertical lines are written as x equals, and then whatever the x value is, 1. So this is a line that's not even in point-slope form. But you could see it come up at times, and so it's good to know how to do it. Sometimes you could be given a point and an equation, and they say they want you to write the equation of a line that goes through the given point, and in this case will be parallel to the equation given. So what we need again are a point, which we have, and a slope. This equation is in slope-intercept form, so we know the slope is -1. That is our m value. We want our line to be parallel, which means same slope. So we have our 3 pieces of data. We plug it straight into the equation. Remember, it's subtract your y values, plug in your m, subtract the x values. So that's the base equation. We just got to substitute in our values. X is 1, y is 0, m, your slope, is -1. So notice that y minus 0 is still y. I would simplify this just a little. Y equals -1 times x minus 1. And your equation is now written. Slightly different example now. We're still given a point and an equation, but this time they want us to do a perpendicular line. My equation's in slope-intercept form. I know the slope of this equation is -1/4. But for a perpendicular line, remember, you want to use the opposite, reciprocal. Opposite meaning positive. Reciprocal says flip it. 1/4 now becomes 4/1, or simply 4. That is the slope we want to use. So we go back to the same base equation. Y minus your y value equals your slope times x minus your x value. Plug in your values. X value is -5. Y value is -1. And your slope, the one we want to force this to be perpendicular, is 4. Now, it's worth noting there's some simplification here as well. First negative came from the equation. Second negative came from the given point. Opposite of a negative is a positive. So we're going to rewrite this now as y plus 1 equals 4 times, same thing here. Opposite of a negative is a positive, x plus 1. There's your equation written in point slope form. Just about there. One more example. What if you're given 2 points instead of a point and an equation? Well, 1, you're going to find the slope using your slope formula. 2, you're going to plug in a point and the slope just as we have been doing above. So for this example, the 2 points we're going to use are 2, 5 and 1, -5. Remember, we can find this by just stacking our 2 points. Change the sign of the bottom point. This is still using the slope formula, just a slightly different setup. And do the operation straight down. 2 minus 1 is 2. 5 plus 5 is 10. Slope is rise over run. And would be 10/2. That can simplify to 5. This is the slope I want to use. And I have 2 points to choose from. It really doesn't matter which one I use. Once again, the base equation, y minus some y value, is equal to your slope times x minus whatever your x value is going to be. 3 pieces of substitution and we'll be done. Our slope we know will be 5. Both of these points are on the line, so both of these points will satisfy the equation we're going to create. I'll pick the first one. 2 is the x value, so your x's go together, x minus 2. 5 is the y value, so the y values go together. No simplification to be done. The equation for this line is y minus 5 equals 5 times the quantity x minus 2. And this covers our third form. We've done slope-intercept form. We have done standard form. And now this one, point slope. You're given a point and a slope. Just got to substitute those 3 pieces in. The biggest thing that catch people is you have a negative from the equation, and sometimes the point gives a negative as well. As long as you're watching out for that, you'll be able to do this. And that's all you need to know about point slope form.